Hi, I'm Heimo Laukkanen from Siili Solutions in Finland, and I am presenting this talk with my awesome colleague Arttu Kaipiainen from Wunderdog. For some time, we have been working together as consultants at YLE, the Finnish public broadcasting company. And today we are talking about the product development project we worked on. So, just to set the expectation right, what should you get out of this talk? First of all, you will hear a case study about the project, where Clojure was used both in backend and in the front end. You will hear about the overall architecture we built and why we built it that way, and what we learned from the development work both in the backend and in the front end. So, Clojure-powered chat tool. Why would anyone want another chat tool? After all, the market is already filled with well-productized tools and services, and global services like YouTube, Twitch, and Facebook already provide great chat features alongside streaming. For us, the chat was not the point or the main point. The point is creating interaction with audiences and also within the audiences. From the start, we saw the chat just as the first form for such almost real-time interactions with the audience. And the whole project is also learning experience for creative people who are developing programs. Much of the media is still not interactive with audience. There are no established patterns, and this is a whole new domain for creative workers. What can they do with interaction with the audience? What can they do with audience which interacts among other audience members? What kind of forms these interactions could take in the future? And to start, we selected the most simplest form that everyone knows, so text-based chat. We got to work with an excellent brand called Dog Ventures. To those of you who do not know it, it's a talk show in three parts. The first part is a setup, a context for the evening, and setups a documentary. Then in the second part, a documentary is shown, and in the third part is the actual talk show where the hosts and guests are discussing the topic and themes of the documentary. It is made by a superb team of professionals, and we were lucky that they were willing to try out new things. We got to work very intimately with the production team and actually worked right there with the creative people during the live events. We were reacting and learning how the audience is interacting and behaving in this new channel. The chat was not just an add-on to the show, it was actually connected very well with the TV broadcast in multiple different ways. What happened in the chat affected the broadcast, and what happened in the broadcast affected what happened in the chat. For example, the broadcast showed key insights and comments from the participants in the chat. Broadcast also showed poll results from the chat audience, and from time to time it also had interactive elements to like what should happen next, decided by the live audience in the chat. We worked together with the creative people and tried to figure out how these capabilities could be used to improve the show and create something meaningful to participants. What was a positive surprise was that the chat allowed us to see in almost real time how people reacted to topics, and also get a pulse on how participants are present during the show. The graph here shows active connections to the system on any given moment. And the form of the graph shows us the three stages of the show. First, there is the pre-show before the documentary, and people come to the show and start the discussion. Then there is a small dip down as the documentary is shown and mobile devices go to sleep when people leave them on the table. Then there is a new activity as the documentary ends and people return online to participate and follow the discussion in the chat. Seeing active participation in real time also allowed the show to know more about the fans and recognize who are the most active contributors there. One of the most active participants was called through a phone call during a live event. This was about working with the community, the fans of the show, and participants were no longer just passive participants, but really active members of the show. And even more, many participants commented that they got more from the show because of they got to see and read how other people reacted to these same topics. So they were no longer alone. They were part of a larger community of people. And you could say that this show was liked, and you really don't need to take just my word for it. It was also liked by many other people in the television industry. And the program won a Venla Award in its own category. And I don't know much about awards and such, but apparently this is a big thing. And the statue was nice, and the party was also nice. After Dog Ventures, we got to use the chat also in other places, like in the Independence Day Ball. It was a great show, and there was a great chat. And we also got to participate in the Finnish qualifiers to the Eurovision Song Contest, which was also nice. This was actually the closest thing that we got to experience of hyper chat, since there were so many participants experiencing the joy and excitement of the evening. It was exciting to see how audience reacted in real time to the show, especially as we were discussing about really important topics, the songs. So I still admire the energy people had in the chat. This was about doing and being together with the Eurovision community, though some people thought that the wrong artist won. We also had chat for Oscars in the middle of the night in Finland, but funny enough, there was a large group of movie fans online discussing the movies with the movie experts from YLE, and they were there throughout the whole night. And then came COVID-19. So from all this entertainment and fun, it was suddenly almost like apocalypse. People hoarding toilet paper and putting on masks. So for us, it meant that we had the opportunity to help the nation, and the chat was used in news broadcasting to interact with the audience and offer guidance and answers. YLE had medical experts right there in the chat as well as in the studio. Live broadcasts were held on multiple days, and journalists got excellent material about what people think, what people fear, and what things are in people's minds. So from being a tool used in entertainment, it transitioned quickly to being used in serious news context and put in the front and center in news broadcasting. And even though the team was commanded in the remote work mode, everything worked great. Here we see one of our moderators moderating the chat while being on the road. So this was fine. Eventually we also got back to collaborate again in entertainment shows, and the chat was also embedded to be used in the Yle Areena, the YLE Areena streaming service. Yle Olohuone, YLE Living Room, was a show with a performer doing a live gig in the broadcast, and the audience was able to interact with each other and with the studio in the chat and via WhatsApp channel. Because naturally, not everyone is still registered to the YLE services and not going to register to YLE services just to send a request to an artist. So multiple different channels were used at the same time. So how did we build this thing? When we started the project, we had no idea how successful this would be and what kind of scale of use we would need to be ready for. As YLE is known for big events, we wanted to be able to support events with even hundreds of thousands of users. Not that we would be there from the start, but to be able to grow there. We selected a very decoupled architecture where front office and back office are clearly separated and can scale independently. Back office is mostly about supporting moderation and managing the data, so it does not require that much performance. Front office, on the other hand, supports the whole user experience, and each user connected to the system takes some amount of computing capacity because of the active WebSocket connection. In the front office, we selected to use DynamoDB for massive scale votes like the Eurovision Song Contest. Published chat data was stored in Redis stream, which is really fast to use and browse. And Redis was also used to store other chat state data, so that all the instances of these WebSocket APIs would share the same state. End users connect to the service either with the web browser through chat.yle.fi or with yle mobile phone application. In both cases, the user interface loads a ClojureScript-based JavaScript widget, and the widget then connects to the WebSocket API and keeps the connection open to get new messages from others and send users messages to the service. So after the initialization, everything works as event-driven from that point on. So if a user does something, the system sends events downstream to the WebSocket server, and if the events are valid and the user is not blocked or throttled, then those events are passed on to the back office via Rabbit message queue. Eventually, when the user's messages are accepted or rejected, reply messages are sent back via Rabbit to the user himself or herself, or to all the users if the messages were accepted. So the front office and back office are decoupled from each other through shared infrastructure. Of course, the shared infrastructure, the Rabbit messaging could be a bottleneck, but even today it handles thousands and thousands of messages per second, so we are kind of good for a long time. The real bottleneck in the system is the human moderation that is required for all the messages. What did we learn? Well, as with any Clojure library, you really need to test things to be sure. We found out that the HTTP server started to break up with Center under high load, so we had to quite quickly switch to Aleph, which worked perfectly. Center proved to be a nice choice in terms of how easy it is to take into use, and it handles some rough edges about WebSocket connection handling for us. So there are some things in Center not to like, but those are things that we can live with, especially as we didn't want to build our own infrastructure handling for the WebSocket connections. So we are happy with it, and we got the product ready with Center. So thumbs up because of that. Of course, one thing to remember with Center is that as the message handling runs in a Go loop, you need to keep your message handling functions really fast, or they can become a bottleneck because there is no free threads to handle the operations. It's also important to test the system under realistic data and load, because you might find out that your bottleneck is somewhere else where you think it, and especially if your algorithms start to behave differently when you have more data. We had some surprises where we learned that Redis is actually super fast compared to doing things on Clojure side. We could have optimized our Clojure code, but it was just way simpler to push some work to Redis and use Redis's really fast set operations. Of course, this means that eventually Redis could be a bottleneck, but we are way away from that. And Redis was really sweet to take into use on Clojure side because the Carmine library is so up to date and easy to use. So it was just a small operation for us. For load testing, we used a service called float.io, and during our project, we actually experienced that the WebSocket support in Kotlin scripts got broken during the project, and nothing actually happened in terms of fixing it while we were actively developing. Luckily, the problem was only in reporting, so we were able to generate high loads, but we didn't get the proper reports from the service compared to regular REST-based HTTP tests. So it was a slight annoyance, and we didn't have the quantitative data for our decisions, but we still were able to check on, put the check mark on the first part of load testing, that see how the system behaves under a very stressful load. And of course, when doing work in such distributed environment, debugging can become complicated. Of course, Clojure and immutable data structures with message passing between these different components helps, but you still need to deduce what is going on in the system based on some data. So to help some head scratching, think beforehand how you can help yourself to make sense of the state of the system when the data is flowing there, before you actually need to have it. And this was something that we learned well during the project, and improved the capabilities of figuring things out week after week from the experience of debugging problems during the live events. And from here on, I'll switch on to Arttu and lessons from the front-end development.
Hello. Like my excellent colleague Heimo already said, I'm Arttu Kaipiainen from Wunderdog, and I'm going to tell you about things we learned when we made the front-end with Clojurescript. As the main framework of the application, we used Reagent, which is in my opinion the only reasonable choice for Clojurescript. It's a React interface for Clojurescript that is well maintained, and even though it has been a bit behind React's newest features, it has now caught up with the best React improvement in the recent times, which is hooks, with support for React function components in Reagent version 1.0. In this project, we didn't use any data store library and went directly with Reagent atoms, since we had already used the same method in previous Clojurescript projects, and the front-end's complexity didn't require anything fancier. If the project needed a data store library, I would definitely suggest Reframe, which has a great data and event-driven model. It would also combine excellently with Sente's event-based communication model, where you can just hand off Sente's WebSocket events for Reframe to handle. Like Heimo said earlier, we used WebSockets and Sente for communication with the backend. Because of the nature of a chat, the WebSocket's ability to push data from the backend was very important to us, and Sente made the data flow feel very seamless, just sending a Clojure data structure from one end and receiving an event with the exact same data at the other end. This becomes especially apparent in a full-stack Clojure project, where you can use the same code for both the backend and the frontend. In our case, however, we made all the parts separate from each other, so we didn't get the full advantage of code sharing between the Clojure and Clojurescript parts of the project. For the build tool, we went with the newest iteration of Figwheel, which is called Figwheel Main. In our previous Clojurescript projects, we had used the old Figwheel, and the new tool is a very nice improvement. It offers hot reloading, compiler error messages in the browser, a well-working REPL, and a fantastic test runner, and it makes the development experience really smooth. And best of all, everything just works out of the box. There's no need to write 100 lines of webpack.config.js. Most JavaScript developers must know how frustrating it can be to set up a smooth development environment, and Fig Wheel Main let us skip all the trouble and get straight to business. All in all, Clojurescript lets you have the data processing power and REPL-based workflow that you're used to, also in the front-end development. Of course, we also met some difficulties during the project. Like many front-end developers know, targeting multiple platforms with the same code is not easy. Our chat needed to look and feel good on the desktop, in the mobile browser, and also in the native application on both Android and iOS. In addition to the usual difficulties with responsive web pages, the WebSocket connection actually gave us a lot of trouble, with many differences between the different platforms. Even though Sente has a decent automatic reconnect feature, we still had to go through a lot of trial and error, and in the end write our own code that tries to detect a broken connection and force Sente to reconnect. Many of these difficulties had to do with mobile platforms and what happens there when the page or app goes to background or the device is locked. Another problem is that the Clojurescript ecosystem is still very small, and there are few libraries available compared to the JavaScript and React ecosystem. Of course, using JavaScript libraries is possible, and we had to do so in few parts of the project. And the CLJS project helps with using JavaScript libraries, but the JavaScript interop is a pain, especially with React libraries, since Reagent and React have quite different approaches, as do Clojurescript and JavaScript themselves. The newest version of Reagent thankfully helps a bit with its support for easily using React hooks. In cases where JavaScript interop was needed, we found that writing a separate wrapper for the library and then using that wrapper in Reagent components is often simpler and easier to understand and work with than doing interop directly in the Reagent components. Many patterns that are common in React and JavaScript frontends are also unavailable or uncommon in Clojurescript. For myself, the thing I missed most was styled components or a similar library for defining style sheets in the components, instead of going the old-fashioned way with less or Sass. Well-working server-side rendering of Reagent is also not really possible as far as I know. The third obstacle in our path was the simple fact that most front-end developers at YLE are only familiar with JavaScript and its variants, and most Clojure developers are only familiar with the backend. This made it quite difficult to find people at YLE that could help us with the front-end part, so we were unable to use a lot of existing front-end experience, especially related to difficulties on mobile platforms. To sum everything up in 2 points, the Clojure is a fantastic language for data processing, and its tooling allows developers to iterate and try things out very easily and quickly. And the flow of data through the application feels natural and easy to work with. Clojurescript, on the other hand, still has a lot of improvement to be done, and still isn't a risk-free choice for your frontend. As much as I hate to say it, the ecosystem and general expertise is currently better on the JavaScript side, even though Clojure as a language appeals a lot more to me. And that is all for us now. Thank you very much.